Hello, good morning students. So in our previous video we have discussed about the introduction part of your number system. So today we will be discussing about the properties of the number system. First we will be discussing about the properties of your natural number, whole number and integers. Then only we will be proceeding further for your next, that is the properties related to the rational number. So in the properties of the numbers, as you can see on your screen, there are different properties. First one is your closure property, second one is your commutative property, and the third one is your associative property, and the fourth one is your distributive property. So coming to the first one, that is your closure property. In closure property you are having four things. First one is your closure property under addition, okay. Second one is your closure property under subtraction. Third one is your closure property under multiplication, and the fourth one is closure property under division. So today we will be discussing about all these four properties, okay. So first we'll be discussing about all these closure property of under addition, subtraction, multiplication and division. Then only we'll be proceeding further to the commutative property and associative property, then distributive property. Now coming to the closure property under addition. So one thing you must be knowing, जैसे हम लोग ये बोलते हैं ना हिंदी में कि आम के पेड़ में आम ही हो सकता है। अगर हम लोग एक आम का पेड़ लगाएंगे तो उसमें जो हमें फ्रूट्स मिलेगा वो आम ही मिलेगा, कोई दूसरा चीज़ नहीं मिलेगा। सिमिलरली मैथमेटिक्स में भी यही क्लोजर प्रॉपर्टी यही कहता है हमें। क्लोजर प्रॉपर्टी अंडर एडिशन सेज दैट ए नंबर सिस्टम इज सेड टू बी क्लोज्ड अंडर एडिशन इफ एंड ओनली इफ द रिजल्ट ऑफ द सम ऑफ द टू नंबर्स इन ए सिस्टम ऑल्सो एग्जिस्ट इन दैट पर्टिकुलर सिस्टम। इसका मतलब ये है कि अगर हम लोग कोई भी दो नंबर को जोड़ेंगे, मान लो कोई दो नेचुरल नंबर लेते हैं या कोई दो होल नंबर लेते हैं या कोई दो इंटीजर्स लेते हैं। अगर दो नेचुरल नंबर लेते हैं, सो द सम ऑफ द टू नेचुरल नंबर्स मस्ट बी गिविंग द आंसर और द result as a natural number only. If this property or this thing validates or follows, then we can say that the natural numbers are closed under this addition. So as you can see that in number system, the first example which I have taken is a natural number. You can see here the sum of two natural number is always a natural number. For example, here it is written 5 plus 7 is a 12. So we know that 5 and 7 both are natural numbers, and the sum which you are getting, that is 12, 12 is also a natural number. So we can say that natural numbers are closed. Natural numbers are closed under addition. Now coming to the second one, that is whole numbers. So when I am saying the sum of two whole number is always a whole number, that means what? If I will be adding two whole numbers, so whole numbers means the group of numbers or the set of numbers starting from your 0 to infinite. All these positive numbers are known as whole numbers. There is no place for any fractional number, any decimal number or any negative number. So when I am here adding 8 plus 3, so as you can see, so 8 plus 3 is equals to 11. So 8 and 3 both are whole numbers and 11 is also a whole number. So we can say that whole numbers are closed under addition. Now coming to the third one, integer. So it is if two integers are added together, then the sum must be an integer. So you can take any two examples of two integers. Let I am taking two examples. One is your 2, another is your minus 3. So 2 minus plus minus 3 will always give you what? As minus 1 as your answer. So when I am saying you are getting minus 1, so 2 and minus 3 both are your what? Integers, and the answer or the sum which I am getting minus 1 is also an integer. So we can say that addition of integers is also closed. Now coming to the second property, that is your closure property under subtraction. The same thing is also discussed here. So when we are subtracting two numbers in a number system, आप कोई भी एक नंबर सिस्टम ले लो। नंबर सिस्टम का मतलब आप नेचुरल नंबर का सेट ले लो या होल नंबर का सेट ले लो या इंटीजर्स का सेट ले लो। कोई भी एक नंबर सिस्टम में अगर हम दोनों नंबर सेम टाइप के नंबर लेंगे तो उनको एक से दूसरे को घटाने के बाद जो हमें डिफरेंस मिल रहा है, सो डिफरेंस मीन्स व्हाट? घटाने के बाद जो हमें आंसर मिलता है हम उसको डिफरेंस बोलते हैं। क्लियर? ऐड करने के बाद जो आंसर मिलता है हम उसको सम बोलते हैं, SUM, सम, डिफरेंस। सब्ट्रैक्ट करने के बाद जो मिलता है हम उसको डिफरेंस कहते हैं। So the same thing is it is said a number system is said to be closed under subtraction if and only if the result of the difference of two numbers in that system also exist in that system. तो इसी चीज़ को हम लोग एक एग्जांपल लेके समझने के लिए कोशिश करते हैं. नेचुरल नंबर में हम लोग देख सकते हैं कि मान लो जैसे हम लोग दो यहाँ पे नेचुरल नंबर लिए हैं, एक है आपका -5, दूसरा है आपका 7. सो 5 - 7 you will be getting the difference or the answer as -2. So 5 and 7 both are natural numbers, but the answer which I am getting, that is -2, that is a negative number. So negative numbers are not included in the group of natural numbers. So we can say that -2 is not a natural number. So but the numbers which we have already taken, that is 5 and 7, they are natural numbers, but the answer which we are getting is not a natural number. So we can say that natural numbers are not closed under subtraction. Similarly, whole numbers, you take two whole numbers, one is your 0, another is your 5. So 0 minus 5, answer is your -5. 0 and 5 both are natural numbers, but -5 is not a natural number, sorry, whole number. So therefore we can say that whole numbers are not closed under add subtraction. Now coming to integers, when we are taking two integers, first is your let -8, second is your 4. So -8 minus 4, that is your -12. So -8 and -4 both are integers, but you can see that -12 is also an integer. So integers means what? As you already know that integers are the set of positive natural numbers, negative natural numbers along with 0. So here -12 is a negative natural number. So we can say that the difference which we are getting when we are subtracting an integer from another integer is a integer. So we can say that closure property of natural number satisfy that property? No. So it is not closed. Similarly, whole numbers, it is not closed. Integers, yes, it is closed. Now coming to the third property, that is closure property under multiplication. So in a number system, if you will be multiplying two numbers of the same number system, then the product which you are getting, that will be a number of that particular system only. So that is your closure property under multiplication. So here, as you can see in the example, so here I have taken two numbers, one is your 9, another is your 6. So 9 and 6 both are natural numbers. So when I am multiplying both the numbers, I am getting answer as 54. So 54 is a natural number. So we can say that product of two natural numbers is a natural number. So natural numbers are closed under multiplication. What? Natural numbers are closed under multiplication. Now coming to the second one, that is we will be taking the group of numbers or the number system, that is your whole numbers. So in whole numbers, here you can see that the two numbers which I have taken, one is your 0, another is your 5. So when 0 is multiplied by 5, the product which you are getting is your 0. So 0 and 5 both are whole numbers, and the 0 which you are getting as the product or the answer after multiplying both the numbers is also a whole number. So we can say that whole numbers are also closed under multiplication. Now coming to the third one, that is what? Here product of two integers is always a integer. That means what? When we will be taking any two integers, let first one is your -8, second one is your 4. So -8 when multiplied by 4, the product which you are getting is -32. So -32 is also a integer. So we can say that natural number, whole number and integers, all these three set of numbers or the group of numbers or the all these three set of numbers or the number system satisfies closure property. Okay, now coming to closure property under division. So the same property, closure property under division, we can say that when a number of a particular number system is divided by another number of that particular number system, we can say that if the answer or the quotient which you are getting is the same number of that particular number system, then we can say that that is following the closure property. So now coming to the first one, that is your natural number, we can say that the division of two natural numbers is not always a natural number. So as you can say that, let the first example which I am taking is 5, second example which I am taking is 7. So when I am dividing 5 by 7, so let the answer is 5 divided by 7. So 5 divided by 7 is a which type of number? Is a fractional number. 5 divided by 7 is a fractional number. So I can say that 5 and 7 both are natural numbers, but 5 divided by 7 is not a natural number. So the natural numbers are not closed under division. So we can say that natural numbers are not closed under division. Now coming to the second one, that is we will be discussing about the whole numbers. So in whole numbers, as you can say that the division of two whole numbers is not always a whole number. So taking an example, we can say that 4 divided by 0 is not defined. So you can see that it is written not defined. Why not defined? As in previous classes, it's already been taught to you or already discussed with you that when you are getting 0 in the denominator, then the answer is not defined. Not defined means you cannot find the value of that particular answer. So simply if you will be dividing 4 divided by 0, so like this small students, we can say this division process will never end. So we cannot find this value, that is, so this quotient which you will be getting, that is not defined. We cannot find the value. Clear? So therefore we cannot say that if we cannot find the value, then we cannot say that that particular number is a whole number. So we can say that whole numbers are not closed under division. Now coming to the third one, that is what? Your integers. We can say that in integers, the division of two integers is not always an integer. For example, we can say that let first integer which I am taking is 3. The second integer which I am taking is let 6. 3 and 6 both are integers. So when I am dividing 3 by 6, I am getting answer as 1 by 2. So when I am writing 1 by 2 in decimals, I will be writing 0.5. Clear? But you can see that you can take 1 by 2 or 0.5. 1 by 2 is not a integer. 0.5 is also not an integer. 1 by 2 is a fractional number and 0.5 is a decimal number. And fractional numbers and decimal numbers, both these type of numbers are not included in the group of or the set of integers. So we can say that natural integers are not also closed under this property, that is closure property. So we can say that natural numbers are not closed. So let I am giving a cross sign. Whole numbers are not closed and integers are also not closed. That means all these natural numbers, whole numbers and integers are not closed under the property, that is your closure property. So in our next video we will be discussing about the next property, that is your commutative property. So one thing is given as task for you. You take at least 2 to 3 examples of each set of number. That means take 2 or 3 examples of natural number, 2 or 3 examples of whole number, 2 and 3 examples of integers, and try to add them, try to subtract them, try to multiply them, try to divide them, and find whether the answer, the sum, the product, the difference or the quotient which you are getting is a number of that the same group which you have taken or not. If the number which you are getting in the answer is the of same number system, then we can say that it is closed, otherwise it is not closed. It is a very simple concept. If you will try to get this concept by learning by doing method, it will be very easy and you can get this concept throughout your life. Many students do what? They used to forget this property, closure property, but this is an important property because in our further classes we will be discussing about this property in a broad way. Okay, thank you.